In this video, we are going to divide powers with like bases, but a quick refresher is you're talking about exponents, and what is an exponent? That it's just a repetition of the same value multiplied together. So it's just a shortcut of repeated multiplication. And so you have a bunch of x's multiplied together. Shortcut is x to the third. Anything raised to the zero is a 1. If you have negative exponents just move. So it still keeps the value. It just takes it and brings it into the denominator, or if it's in the denominator, it takes it out of the denominator. That makes it a positive exponent. Okay, so with division, we are going to put this together. And so the property that we're going to be looking at is you'll have something divided by the same something, but there's a different amount of them. So the idea is that on this one, you have 5 x's on the top, and you have 2 x's on the bottom. And so there is a property to this, and we're definitely going to go through it, but I think of this a little bit different. But here's the math behind it is that I look at it as 2 of these x's are going to cancel 2 of the x's on the top and leave you with 3. So the math to get there is you're going to take the top power, and we're going to subtract the bottom power, and that's going to leave us with what we have left. Okay, and I'll show you a little bit of a different thought to this. But the property is x to the top exponent minus the bottom exponent. Okay, so on something like this is a first power, so it's a to the second power minus the first power, which is really just a to the first, which the simplified version of that just looks like that. These don't go together because they don't have the same base. So it's not a 7 minus a 5. There's literally nothing you can do to it. All right, and then something like here, you're looking at m to the 3 minus a 3, which is m to the 0. Remember that anything to the 0 is 1. And so that just becomes 1. Okay. And then this one, here's why I don't love this property is when you have this type of a situation, because you have an extra step if you do it this way. So we would take y3 minus 4, which is going to get you a negative 1. But now I have a negative exponent, and typically we don't want to leave things with negative exponents. And so then you have to finish this by taking this value, making it a fraction, and this whole thing is going to move down because negative exponents just tell you need to move. So that becomes 1 over y to the first. Okay, I look at it a little bit different. I look at almost all of these and just go, I'm going to have x's canceling each other. I'm going to have x's or y's canceling each other. I'm going to have m's canceling each other, right? So I look at it as, where do I have more? I have more x's on the top than I do on the bottom by 3. I have more y's on the bottom than on the top by 1. So if I were to take that approach on this, I would just have more x's on the bottom by 3. So when I cancel everything, I'm going to cancel 5 of the x's on the top with 5 of the x's on the bottom. There's my subtraction, and I'm going to have 3 left over. Right? So that's the way I look at it. If you want to do the property, nothing wrong with it. You're just potentially going to have some extra steps from time to time. So we would take top power minus the bottom power, which would get us a negative exponent. And then I'd have to rewrite and put that negative exponent, the whole piece, down to the bottom to make it a positive exponent. So again, if I do it this way, I look at it as I have more a's on the bottom than on the top by 3. Okay, and then you got a couple more. So again, you can do the property. I just look at this as I actually adjust any of my negative exponents first. I don't want to deal with the negative exponents at all. So to me, negative exponents go down or up depending upon where they start. And if that happens, you had 2 y's on the bottom, but you're bringing 3 more to it because you had to move it. So then that is not even a subtraction problem anymore. We're just combining our y's together, and now there's 5 of them. You had 2, you're bringing 3 more to it. So like here, negative exponent on the bottom, I make it a positive exponent just by moving it. So that's going to go up. And so that's going to become, I had 3 x's on the top. I'm bringing 5 more x's up. And I have x to the 8. All right, and then last 2. You can kind of treat this as 2 separate problems. You have 7 x's on the top, 5 x's on the bottom. We got more x's on the top, so 5 of those are going to cancel 5 of those and leave us with 2. And then you have to just simplify your fraction. You're really looking at a 12/8. And then you have these x's that you have to deal with as well. So 4 goes into both of those. 2 times on the bottom, 3 times on the top. So you still have a 3 on the top, and you still have a 2 on the bottom, but you also have 2 x's on the top. Okay. And then the last thing, if you have a's and b's, that's fine. Just try to figure out where you have more. You have more a's on the bottom by 2, and you have more b's on the top by 6. Okay. And that was dividing powers with like bases.